Yes,
कैसा चल रहा होमवर्क?
सर होमवर्क किया मैंने।
यहाँ यहाँ आने का टाइम कैसे मिला उसको? यहाँ पे आने का टाइम? हाँ, तुम लोग इतना बिजी हो, यहाँ आने के लिए टाइम कैसे मिल गया? तुम्हारे पास सारे जवाब हैं। चलो ठीक है, अभी क्या कर रहे थे हम लोग? लास्ट क्लास में कहाँ रुके? Today the strength is very less. बाकी कहाँ? ऑनलाइन कितने हैं? अर्नव धर, वीडियो चालू करो अर्नव। अच्छा, तुम आज ऑनलाइन हो। फिर विस्मय, विस्मय कौन है? विस्मय
सर मैं हूँ।
मैं मतलब दिखो तो सही। हाँ अच्छा, और ये विश्रुत, विश्रुत बैठो जरा। आज क्यों तुम लोग सब ऑनलाइन क्यों हो गए?
सर काम था इसलिए।
अच्छा ठीक है, चलो ओके। कहाँ पे रुके तुम लोग लास्ट क्लास में? वो तो हो गया, उसके बाद इमेज फॉर्मेशन हुआ था। किसका किसका? हाँ, ऑब्जेक्ट एट इंफिनिटी सारे हो गए। फर्स्ट केस हुआ है। ओके, सो वी हैव डन we have to do case 2. Or far away off. Okay, let us see. Yeah, it was a tragedy actually. So nothing can be done by us for that. Let's focus here. We are very sorry for whatever has happened and pray for their solace. Let's get back. So what is this? You have a convex lens here. So when the object is far away, right? What is the nature of incident rays?
पैरेलल।
They are parallel, but they are not parallel to principal axis. Okay, so they are parallel to each other, but they are not parallel to principal axis. In such cases, what you do is, so you draw first the ray passing through O, right? Of course, you have the focus marked on both sides, focus and center of curvature. So when the object was at infinity, the image formed at principal focus 2, right? In this case, the image will form here on the plane. It will form at the focal plane. That means image will form here. So the second ray, one ray you take above the line passing through and make it join here. Make it pass through this point. Okay, one ray you take below it. Like this. Okay, so now the image is forming in the image is forming at the focal plane. So image at image at a point in focal plane at F. Okay, so where is the image forming? It is forming now in the focal plane. क्या हो गया? Where is the image forming? It is forming in the focal plane, which is passing through F2. Okay, तो यहाँ पे होगा. ठीक है. What is the nature of image? What is the nature of image? Real and inverted. So this is real and inverted. And what is the size? Highly diminished. So this case and the previous case, they are treated as one case only. Okay, 1 and 2 is same case. So the nature and the image formation is at the same distance from the lens, but now it is forming in a focal plane. Okay, this is only. Now what is the next object position? Next object position will be beyond 2f1. Object beyond 2f1. So in this case, anybody has any question here? Anyone has difficulty understanding this? So first ray is ray passing through O, then one above and one below. And we know that the image will form in F2 only, but not at the focal point, but at some point in the focal plane passing through F2. That's what it is. So now we have the object beyond 2f1. So where is the image forming?
Between F2 and 2F2.
So whenever the object is beyond 2F1, the image will form between F2 and 2F2. Image between F2 and 2F2. Then it is real and inverted. Okay. Okay, so image is between F2 and 2F2, real and inverted. And what is the size? It is image. रिफ्रैक्शन से नहीं ऐसा कुछ नहीं क्यों अभी तुमने कर लिया इसलिए इजी लग रहा है मतलब सिमिलर है ऐसा कोई ठीक है और एड 2F1 तो अभी हम क्या कर रहे हैं ऑब्जेक्ट को लेंस के पास ले गया है ना तो अभी कहां पे रखेंगे 2F1 में So what about its size? Same as the object. Yes. Image at real and inverted. Same size as ठीक है so ये हो गया then फिर object between 2F1 and F1 यहाँ पे ऑब्जेक्टिव दे रहे हैं। So this is UF1, F1, 2 and 2F. So this is now beyond 2F. What about size now?
Larger than the object.
2F. This is real and inverted. What is the nature of it?
Larger than the object.
You come here. Second.
So
Come fast without arguing. Get up. Come in. Continuous chatter loss. So this is magnified. Go get your water bottle. So this is magnified. What is the next object position?
F1.
Object at F1.
Yeah.
So what have we observed so far? All the images are real and inverted. Okay? And as the object is approaching the lens, the image is going away from focus. And its size is increasing. This is the observation. The image is going away from focus and its size is increasing. Yes.
Yes, that.
So this is the opposite of first case. This is the opposite of first case. So here now we are keeping the object at F1. This is KB. So what are we getting here in this case? Huh? What are we getting here? Parallel rays. Therefore, this becomes the case opposite to the first case. When the object is at infinity, image formed at focus. In this case, when the object is at focus, the image will form at infinity. Okay? So, image at infinity. Image, it's very logical. Image at infinity. Then, what is the nature of image? Nature of image is real and inverted. So, all the images which are forming in this quadrant will be real and inverted. You have to keep this in mind. Where is the real and inverted image forming? In quadrant 4. Okay, everybody understand what is quadrant? So this is first, second, third, and fourth quadrant. Real image are forming in quadrant 4. What was the situation for mirror? The real images were forming in quadrant 3. Here. In case of lens, the image position is switched. Okay. So image at infinity, real and inverted. What is the size? Very magnified. Highly magnified. Highly magnified. Very magnified. Highly magnified. Okay. So this is what is obtained when the object is at F1. Now the last object position will be between. What is the last object position?
Between F1 and O.
Yes. So object between F1 and O. So what is the expected nature of image?
Virtual.
Yes. This is the first time we'll see that the rays are diverged. After reflection, we'll see the rays are diverged. So let us see. Is everything all right with you? Does it look like? Be careful, huh? Okay, sit quiet. एकदम चुपचाप बैठो सब लोग. तो बीमारी है मतलब फालतू में बात करनी है. तू क्या हंस रहा है? सुसु नहीं है क्या तेरे को? गया था पास. ठीक है. शांत बैठो तुम. शांत. Now look here. ये है. So this is for the first time we are seeing that the rays are diverging. So whenever the rays are diverging, you are supposed to extend them backwards. Okay, they are waiting somewhere here. So this is the image position. So what is the image position here? In front of the lens, same side as object.
Sir, magnifying glass to like this.
Yes. Image on same side as object. What is the nature?
Virtual erect number.
Virtual and erect. Size
And
only magnified. Highly magnified is only for this case. Wherever infinity is involved, the word highly is involved only when either the object is at infinity or the image is at infinity. Okay. Everywhere else it is magnified or diminished. Alright, so this is what it is. So now the nature has changed for the first time. And this is 7, not 5th. Okay. So we have seen all 7 image formation by convex lens. So anybody has any difficulty in understanding any image formation for any object? Okay. So now let us understand the application also. So there are total 6 object positions. 1 and 2 are treated as same. Okay. So for the position of object at infinity or far away object, where is the position of image obtained?
At f2
At f2.
or in the focal plane.
At which is also at f2, but in the focal plane, right? Passing through f. And the size of image is highly diminished. So what is the application of such a
Something
object?
used to start a fire.
Exactly. You can use the convex lens as burning glass. Okay. Like the faraway object can be taken as sun. The image of the sun you can focus on any paper or anywhere where you want to cause fire. So that can be used as burning glass. Now, the second position when the object is beyond 2f1, where can be used? It can be used in optical instruments such as camera lens, to take photograph of faraway objects. Okay. So that's the second application. Third is at 2f1. It can be used as a lens in terrestrial telescope, right?
wild photo.
Any photograph. So terrestrial telescope में क्या करोगे तुम इसको? Basically, it is slightly misleading. So the image is same size, but now it is inverted. So you can invert the image, right? So you can use it as the second lens just to invert the image. Okay? Because telescope में क्या होता है? Inverted image बनेगा.
So there are 2 lenses used.
2 lenses are used so that the image is now erected. And that. Now, for this, when you keep it between f1 and 2f1, तो क्या होता है? For the first time you get a magnified image. Where can you use it? You can use it in slide projector, right? Slide projector. So you have a small object, you can magnify it. ठीक है? यहाँ पे भी you can use the second lens to invert because यहाँ पे भी inverted image है. Then when you keep the object at f1, right? So this is basically to, what is the application? Collimator. Collimate means to produce parallel beam of light so that it can be fed to spectrometer, which is a device to analyze the spectrum of incoming rays. Okay. So we need a parallel beam of focus light. Parallel beam of light. So उसके लिए object को क्या कर सकते हो? You can keep the source of light at the focus, like torch or in the vehicle. Okay, where the bulb is kept at the focus. So it then produces after refraction parallel beam of light. Okay. So that parallel beam of light itself is called collimated rays. Okay. What is collimated rays? Collimated rays. Collimated rays are parallel beam of light. Okay. So it's like if you keep any light source at the focus, so this is collimated beam. Okay. This can now be fed to the spectrometer for further analysis. So you have a chapter called spectrum.
Yes.
तो उसमें ये यूज होगा. ठीक है. तो बहुत ज्यादा डिटेल में नहीं है. I'm just telling you the purpose where collimator is used. Okay. Then the last is use of convex lens as a magnifying glass. Okay. So you can use convex lens as magnifying glass by placing it very close to object. Then it will magnify the object. Clear? Is this clear? So magnifying glass. Just the object is kept very close to the lens between F and O. Okay. सबने यूज किया मैग्नीफाइंग ग्लास. Next is image formation by concave lens. So here we have again first case is object at infinity. In this case, क्या होगा? When the object is at infinity, image has to form at focus something. But now here the principal focus will be F2. This is 2F2. This is F1. 2F. So when the object is at infinity, rays will be parallel. And this is the diverging length. So the incident ray will be diverged away from focus in this case. Right?
Torch. Torch.
You can, like, you want a wide beam, right? Then you can use this lens. So what is it? This is image at There is one more telescope. What telescope?
Aerial or stargazing telescope or observatory telescope.
Not observatory. It has a special name.
Medium test.
It is called Galilean telescope. Galileo वाला. ठीक है? तो इसमें it is telescope only, but now it forms the erect image. That's the only difference. Image at f2. Okay. Now, nature of image is virtual and erect. Virtual and erect. Why this is not shown? I can't pin this.
There didn't get a
Can't remove.
there it will be on your
Yeah, exactly. Edwin is sleeping, I think. Okay, so virtual and erect. Rajesh? Virtual and erect. And what is it? Highly diminished. ये इसको पिन करो ना यहाँ पे ये दिख क्यों नहीं रहा है बच्चों को बोर्ड यहाँ क्यों नहीं दिख रहा वहां जाके पिन करो यहाँ से नहीं होगा नहीं तो इधर दिखना चाहिए ना वहां से करना पड़ेगा एडमिन से कहाँ हो गया बोर्ड कहाँ आ रहा है बड़ा पिन करो इसको नीचे जाओ हाँ हाँ तो दिख नहीं रहा ना लेकिन यहाँ पे जाके शेयर में सेकंड कैमरा में जाके देखो इधर आ क्यों नहीं रहा दिस इज हाईली diminished. Okay, so where is it used? It is used in Galilean telescope. Used in Galilean. Spelling errors here. Okay. Now here also you can have a faraway object. Now in this case, done. क्या किया? Switch camera किया क्या? वही तो करना था ना? चलो, thank you. Then you have next is faraway object. So faraway object में भी image will be at f2 only but in a focal plane. ठीक है? Let us see how it is done. So far away, take one ray passing through O, one above and one below. What will happen? So wherever this ray passing through optical center is cutting the focal plane, this is where the image will be formed. Yeah. This is F2, F2, F1 and 12. ठीक है? So same image at F2. At a point in focal plane. At F. Virtual and red. So where is the virtual image forming? In the first quadrant. In case of convex lens also you saw that it is, second quadrant. It is forming in the second quadrant. Where? In front of the lens. Image is forming in front of the lens. So it's diagonally opposite quadrants. Real image here and virtual image in the second quadrant. Okay. And what about the image? Highly diminished. Size, highly diminished. It is highly diminished. Okay, so the clue where the image will form is wherever the line passing through O cuts the focal plane. It was also the case with the convex lens. That's where the image will form. Then the third and the final position is so object anywhere between infinity and O. Anywhere between infinity and O. So we have only these two positions here. Now let us say we keep the object somewhere here between say F2 and 12. Okay, so where is the image forming between F2 and O? That always will be the case. F1 and okay, so what is the image position? Image between F2 and O. Then nature is virtual and direct. And what about size? Diminished. So what is the observation here? In
The
case of
image is always diminished.
yes, image is virtual and diminished in case of concave lens always. Whereas in convex lens, the image is virtual and magnified. That's the difference. The virtual image in convex lens is magnified. Whereas in case of concave lens, it is diminished. Huh?
Glasses, yes, sir.
Yeah, it is used for correcting which defect? Myopia. Whenever the far vision is defective, when the eye is not able to see the far object, that's when this diverging lens is used. Used to correct myopia. Okay, used to correct myopia. Myopia is basically short-sightedness. Likewise, convex lens is used to correct hypermetropia, which is long-sightedness. Whenever you are not able to see the nearer objects. Okay, like in old age, everybody have difficulty in reading books. That's when which lens to be used? Convex lens. There is a disease called hypermetropia. Okay. So with this, we have completed. Then there is a small table difference between image by convex lens and image by concave lens. Just take 2 minutes to go through it. It is also in the volume. On page 93. Page 93 of volume, this difference is given.
And short-sighted.
Ness. Sightedness. Yes. This near vision is okay. You can't see far objects.
All near vision is close. Not okay. The far vision.
In your case, which means you have hypermetropia. Now it is corrected. So you are now glass free. What do you did? Laser surgery. Then
Fine. That's fine.
acha. Sometimes it goes away with age. वैसा भी होता है through some exercises. Okay. Next is sign conventions and lens formula. So anybody has any difficulty in any of the image formations? Feel free to ask. I'm here to help. Everybody is okay now? Let's go.
Sir, what's a concave or convex lens used for in glasses?
Huh?
Sir, in glasses, what's a convex or concave lens used for?
Glasses?
The concave or no, the convex or concave lens in glasses.
They are
Sir,
used
what's
together. You mean to say together?
no like what is the concave no convex or concave lens used for?
Concave lens is used for correcting far vision. That is myopia. That's what you're asking?
No, the convex or concave lens.
What are you asking? I'm not getting.
Convex open.
Convexo concave. Acha. That is a mixture of this. So don't know. I mean, it is not in the scope of discussion. Just single convex or single concave. That's the only thing. So if it is there, I'm not familiar. Okay? But you can have bifocal lens in which the upper part is concave and the lower part of the lens is convex. In some lenses. Okay? So
Those
bifocal
reading and
is
far away glasses, those combined lens.
called bifocal. So some eyes suffer with both the defects. And convexo concave combination might be used for chromatic correction, color correction. Because there is some dispersion effect, right? So the image form looks colored. So to negate that, right, a convexo and concave, when they are mixed together, right, there is a combination of convex and concave lens. So it will form a rectangular glass slab kind of a thing. So that is just to kill the chromatic or color aberration, it is called. So that's what I can think of. Okay, but beyond that, not in the scope of discussion. Okay. Even bifocal is not in your scope. Any other question on image formation? Okay, let us proceed. So now we are almost reaching time. We have another how much? 5 minutes? Okay. So we can discuss sign convention. Sign convention for lenses. So this uses the normal Cartesian sign convention. What is Cartesian sign convention?
The graph, the four-way graph.
Yes. Same as Cartesian sign convention. So everybody is familiar with Cartesian sign convention, which is the sign that we use for making graphs. So the x-axis is basically your principal axis. In case of lens, the x-axis becomes your principal axis. So on principal axis, you measure focal length, then object distance and image distance. These three things are measured on x-axis. Okay. And on y-axis, you will measure the size of object and size of image. These two things will measure on y-axis. Because object is kept on the principal axis like this. So the height of object is O, right? And the size of image or height of image is I. Okay? In case of virtual, both O and I will be above. So sign convention is everything to the right of the origin. Origin is the optical center of the lens. So you keep the lens at the cross of x and y axis, which is the origin. The origin is your optical center. So all the distances towards right are positive. So distances will be measured from origin. All the distances towards left will be negative. everything above origin will be positive on both sides. So this is on the y-axis, and below principal axis, this will be negative. Okay. So this is this sign convention. So what is the sign for F now? F is focal length. So for convex lens, it is positive. Okay. What is the focal length, main focal length for convex lens? Wherever the parallel rays converge. So it converges on the right side. Okay. So that is the focal length for convex lens. And what about concave lens? Wherever the parallel rays meet after extension, right? So negative for concave lens. So same was the case for convex and concave mirror. Okay. Now, what about object distance? Object distance is, where is the object kept? Always in the second quadrant. So it is always negative. Negative always. Okay. Where is it measured? On the x-axis. And the last is image distance. Just write F, U, and D, and then we leave. What about image? I told you the real image forms in the fourth quadrant. Where is it? On the right. On x-axis, it is on the right. So positive for real image. And negative for virtual. Negative because it is on the left, on x-axis. Negative for virtual image. Only the sign of image changes. In case of mirror, it was opposite. In case of mirror, it was opposite. Every question.
Bye.
Even. Okay.
Hello. 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 Smiling. Hello. Yeah. Now me. Take. Take.